Well, here we are again, Doug here with your Week 10 MyStatLab Problem 6 example. And in our problem, after getting trounced by your little brother in a children's game, you suspect the die he gave you to roll may be unfair. To check, you roll it 120 times, recording the number of times each face appears. Do these results cast doubt on the die's fairness? So here we have our count. All 6 different faces of your die and how many times they came up when you rolled it 120 times. So let's go ahead and take a look at our problem. Part A. If the die is fair, how many times would you expect each face to show? Well, we would have to expect them to show the same amount on each one, right? So let's think about this. We can go ahead and say that there are 120 times that we roll it. There are 6 different possibilities. So if we decide to take 120 and divide it by 6, then we would expect 20 times for each face to show. The exact amount for each one being the same. So 20 times for each one. Part B, to see if these results are unusual, will you test goodness of fit, homogeneity, or independence? Well, we are comparing the distribution of a single variable, the outcomes of the roll of the die, to the expected distribution of chi-square tests. So the goodness of fit is what we need to do. So the chi-square test of goodness of fit is what we need to be testing. So part C states your hypothesis. Well, we were trying to see if they were fair, so our null hypothesis will be that the die is fair. Then on the other hand, our alternate hypothesis will be that the die is not fair. So part D asks us to check the conditions. The first condition is that the data are counts for the categories of a categorical variable. The categorical variable is face, and the 6 categories are the face numbers, 1, 2, 3, 4, 5, 6. The counted data condition is met because we are counting the number of times each face comes up. The randomization condition states that the individuals who have been counted and whose counts are available for analysis should be a random sample from some population. The randomization condition is also met because die rolls are random and independent of each other. And then the third, the expected cell frequency condition, states that we should expect to see at least 5 individuals in each cell. The expected cell frequency condition is met because we expect to come up with 20 for each one, and 20 is greater than 5. So all of our conditions are met. So the next part, part E, asks us, how many degrees of freedom are there? Well, we have 6 different faces here. So that means our chi-square degrees of freedom is going to be equal to 6 minus 1. I'm pretty sure that's 5. Yes, it is. So our degrees of freedom here are 5. Let's move on to our next part. Find the chi-square and p-value. Now for this, I'm going to let our stats crunch do that. I'm going to pull that up here. See if I can slide that up here a little better. So I've already pasted our counts in here for that so that we can go ahead and do our calculations. This is very easy to do here. So we're going to go to our stat tab, goodness of fit, which we said we were going to use for chi-square. Our observed column is going to be the counts, how many times we came up with each one. So we'll put that in observed. Our expected is going to be that all cells in equal proportion, because we're expecting to have 20 of each one. So we'll say that all cells in equal proportion, and we want to display our expected results here. That's all we got to do, and hit compute. And there we have it. There's our chi-square and p-value right there for us. So let's go ahead and post those here. and our chi-square value, if I can remember what it was, it just went away on me there, is 6.1. And our p-value was 0.2966. So there we go. StatsCrunch did that really easily for us. So there's our chi-square and p-value. So that leads us right down to the bottom, the last number. Part G asks, state your conclusion. Assume that the alpha 05 is a reasonable significance level. Okay, and since the p-value here, 0.2966, is higher than our alpha of 0.05, then we can fail to reject the null hypothesis. There is not sufficient evidence that the die is unfair, our p-value being higher than our 0.05 alpha, so we do not reject the null hypothesis. So there you have it. That was pretty easy, wasn't it? Not too much there. StatCrunch did the hard part, our chi-square and p-value for us. The rest of it we pretty much got there. So that's it. That's all you need to know for week 10, MyStatLab problem 6. Later.